Hey guys, me from the future again. I've just finished the puzzle and I basically spent most of the video doing a type of solution that is too complicated, but not in the sense that you think. You'll see. But then I kind of rewrite the whole thing and then it works basically instantly. So yeah, enjoy the show. Alright, day 11. Cosmic expansion. You continue following the signs for Hot Spring and eventually come across an observatory. The elf within turns out to be a researcher. He doesn't know anything about them missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there. Is my mic working? Yeah. Maybe you can help him with some analysis. Cool. The research has collected a bunch of data and compiled the data into a single giant image or puzzle input. The image includes empty space and galaxies. The researcher is trying to figure out the sum of the length of the shortest path between every pair of galaxies. The sum of the lengths, shortest path between every pair. However, there's a catch. The universe expanded in the time it took the light from these galaxies. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all be twice as big. Okay. So, I mean, the obvious solution is to just add a bunch of empty rows until part 2 changes the requirements or something. Okay, well, we can... Wait, so we have... Okay, so these would double. Would double, so here and here. Okay. Just like add one below, add one to the right. So like here, we can see that now there is 3. Equipped with this expanded universe, shortest path between every pair of galaxies can be found. So 1 to there. So wait, 1, 2, 3. Yep. In these 9 galaxies, there are 36 pairs. Yeah. Is that right? 36 pairs. Yeah, probably right. Only count each pair once. Order within the pair doesn't matter. For each pair, find any shortest path between the 2 galaxies. Only steps up and left, so Manhattan distance. Only write exactly 1 dot or hash at a time. Yep. Oh wait, that's kind of annoying. So the path is allowed to pass through another galaxy, that's no problem. 1, 2, 3, 4, 5, 6, 7, 8, 9 inclusive. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so yeah, we can we just do Pythagoras theorem there a little bit, I guess. We'll get to it. But the point is that this first part of the question, I think, is the tricky one, where instead of actually adding stuff like empty rows, etc., we could instead figure out, how many to the left and how many to the bottom. So for example, if we pass through, would each of these steps like kind of double? No, that's, a lot of complications actually to get a real example. So I mean, this means that this space here expanded. And we're going through. Oh, I wish this was just Manhattan distance, like across and then up. But I think it's okay. I just need to know how this here compares with this one here. Right, you see? Because that there is empty, so going on it actually means one here actually means 2 steps to the right. Find any short path between 2 galaxies using only steps that move up, down, left, or right. I mean, there's surely like some maths you can do, right? You can do a triangle between the 2, figure out some stuff, and I mean, yeah, there's definitely some maths you can do there. Okay, let's pass the input. Okay, if that's big enough. Let's pass the input, and once again, it's a grid. My God, what is up with grids? There wasn't a grid literally yesterday. No, is it day 9 that was a grid? Something. Oh no, yeah, yesterday was a grid. But yeah, I'm gonna do a very similar thing. Const grid equals struct, and we're gonna have an enum. Actually, yeah. Const galaxy equals 0 space 0. So grid, which is going to be an array of U8. I think there's not much need for anything else. You know what? Should we do, because this is I want to attempt something, because this is just binary, and this could really hurt me in part 2 if the puzzle just adds comments or something. Wait, does it have? One way to tell would be the great. Let's just have an array of U sizes and pack the stuff like you know, binary. So an array of U size. Yeah, I'm not very good at this binary mask stuff, so it'll be interesting. It'll be quite cool to try it out. Just kind of out of curiosity, how long is one of the real inputs? 140. So if it's 140, U size won't do. So U1, 128 is as high as it goes. Alright, doesn't matter then. Let's do U128 then. And let's do 2 per row. Okay, and we're gonna do 2 per row just to, you know, be lazy. And this means we're going to have a lot of padding like over to the right side. But it doesn't matter, we can probably have a cutoff index of sorts. Okay. So for inputs, line var line 1, which is a U128, line 2, U128, you're just going to be very empty. Yep. And we're going to have our allocator equals standard.heap.page allocator. What we're going to have is my I'm just going to have universe there. Var grid equals try allocator.alloc, and we're going to allocate an array of input.length times 2, because 2 128s per puzzle input. This makes our solution not the most flexible. It can only go up to 2 5 6, but you know, it's okay. The input is part of the puzzle, so there we are. We're going to keep track index size is 0, and we're going to do grid at and we have to actually, like, you know, read the line, don't we? I'm going to have to read that line. Oh, and then for line, right? For line, an actual character, 0 dot dot. We're going to do line is equal to line shifted over to the left once, ORed with we're going to say bar, I'm just going to say C is equal to U8, and we're going to say, this is like terrible, but it's fine. If underscore C is equal to dot, oh my god, what's going on with the indenting? C is equal to 0, space, else C is equal to galaxy. Dots and hashes. Oh, it's U. Okay, so line shifted over once, but ORed with as U128. Turn 1, yep. Let's see. And we actually need to say if I is bigger than or equal to 128. No, if I is smaller than 128, then we do this. Else we've kind of filled that one up. And we need to fill line 2. And here, we're going to do grid at index equals line 1, index plus 1, line 2, index plus or equal to 2. Okay, print any grid. Unable to evaluate compound expression. Oh, other way around, isn't it? Cool. I want this as binary, if you don't mind. Oh yeah, so it's not going to show us the padding, but 0, so 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And then it has, very suspiciously, a 0 for that second line. And then a 1. Oh, yeah, no, never mind. There's, because, yeah, there's two U things. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay, cool. We have our binary mask. Very cool. Binary mask achieved. So next thing to do is actually the hard thing. Okay, I'm glad I didn't spend that much time on. Yeah, I think every time we do grids, maybe I can just do I can't really do a binary mask for all grids because they're not all binary. Unfortunately, but maybe, you know, I could do something similar. Anyways, I could find the ones. I'm really not. Is there really not a 1 U 2 5 6? Man, this just makes the whole thing a little bit more annoying. Zig U 2 5 6. Oh, this Rust. Whoops. Or is it that my LSP doesn't like it? I'm pretty sure that's not gonna work, but if we can keep it in 1, that'll be grand. Oh, we can. It works. Great. So no need for that second line even. That's great. Delete to there. Yep. There we go. Great. That's very nice. Much tidier. Wait, why is this weird? What's going on? Yep, line shifts over. We take C, where it could be space or galaxy, so 0 or a 1. So, oh. Wait, is that how Zig initializes? That's so funny. You didn't, oh, maybe it was just the pattern that was there before or something. Yeah, let's just double check. The end has 1, 0, 0, 0, 1. Perfect. Look at us using binary. And all in one per row. Brilliant. Okay, so that will work for the regular inputs. Anyways, where were we? Doing actual puzzle. No, I wanted to continue doing that. But, are they? Okay. So let's find the ones that are empty. That'll probably be a good start. To find empty. To find an empty. So, I mean, find an empty row is easy. But you know, yeah, we need to find. If you go from point A to point B, you're probably going to need to cross, you know, some things. But it's definitely worth it to just go on that something once. Anyways, I'm sure there's some nice vector trick or something we can do. Let's just figure out which ones are empty. So let's start with empty rows. And how should we do this? Should we just keep a hash map of all the empty rows and columns? That seems overkill, like really overkill. But or you know, since the whole apparently today's theme is binary, let's say var rows equals u12125, and we can keep that stuff in binary as well, which will be pretty cool. So for grid, maybe we don't even need that struct up there. For grid, we have a row. If row is equal to 0, let's take an index as well. Rows is equal to rows shifted over 1, ORed with as u125, ORed with a 1. Yeah, that's fine. We don't actually need the index. I thought we did, but and continue. Otherwise, row equals rows shifted over once, like this. Let's print this. Empty rows. And we've got to start from the bottom. 0, 1. Rows equals 0, shifts over once, twice, thrice. I feel like that 1 is like, should be 1 further. Then it has the gap of 3. 1, 2, 3, 4. Yeah, I mean, correct, but not correct. Maybe if I keep a 1, start with 1. So what am I I guess looking for here? Oh, look, yeah, the bottom is not really what I want. I guess I really want the I want it to start at 0 for sure. And if the row is 0, shifts it over. But we do need like some sort of marker. Okay. 0, 0, 0, 1, 0, 0, 0, 1, 0, 0. Okay, I mean that's fine. We can work with that. And for the columns, which also start 1, we're going to want to do very similar thing, but we want to go grid.length do an I. Grid 0 dot length I. Yeah, we're checking vertical, so like this. That's pretty annoying. So we're just going to check is empty or something. For empty, it's true. For grid row, if row is not equal, no, not, we actually want to get row and as U256, we want to shift over 1, shift it over, how many times? Oh god, where are my rows? Yes, like that one. I want to shift it over I. I'm not sure that's, I think I have to truncate that to be a certain thing. Zig will, it will complain at me, I'm pretty sure, because it doesn't want to do bit shifts of U sizes into this. Yeah. Alright, yeah, I need to kind of check my maths there. Right, so if we have 0, 0, 1, 0, 0, that's the thing I want to check, or like 1. And I currently want to see if there is a 0 on here. I'm going to take the number 1 and place it there, and then AND. So actually I'm going to shift it over the max number of times, not the max, but oh god, I'm really just forgetting how to do this stuff. So look at the rows. Now look at these. Starts off with 1, 0, 0. Yeah, which means we need to check the very left column. Right, we're going to need to take an integer. We're going to need to take a binary number over this number of times. So actually, we're going to take over I, which is the current column. Grid 0 dot length minus I is not equal to 0. Empty equals false, and we break. If empty, if not empty, we do this, but with calls. Otherwise, we do just shift over. And why is that not going to work? And then let's do inputs. What was this one? Oh, does not support indexing. So 0 dot dot to there. Unable to resolve comp time value. Yeah. Value being cast to comp time int must be comp time known. Oh, now. This is where I really cannot remember where to do some stuff. There's a lot of bit shifting being done. This is another project of mine where I used a lot of this stuff. So yeah, I think I just need to force it to be truncated. To what's log 125? I think it's 8. U8. Truncate. Interesting. Truncate. Yank to bracket this. Truncated. Left hand side of shift must be a fixed width integer, or the right hand side must be compile time known. As U8 Oh no, that's just going to run into the same issue. Minus I, so that gives me a U8, and hopefully I could just do this, right? Yeah, I can't remember now, because I do just want okay. Make sure calls worked. No, it did not work at all, actually. If not empty. Let's do one row, one singular row. So the rows is 1, 0. So yeah, basically none. And then the marker here is 1, 2, 3, 4. 1, 2, 3, 4. Oh, that's not okay. Was there a length? So what are we trying to check here? We're trying to get, this is really annoying. Just trying to shift some stuff. Literally, that's it. Just trying to shift some stuff. 0, 1, 2, 3. Galaxy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it was like it was just an off by 1 error. Great. Empty, empty, empty. Cool. Yeah, but look how busy that is. Like, that's just not okay. Zero, 0, 1, 0, 0. Yep. So we start off with 1, 1. Do we actually go through the whole row? Oh. Let's debug. Left binary. Ah, it serves me right for trying to learn a new skill or sharpen an old skill. One sec. Oh. There we go. Look, you wanna show up on camera? Come here. Oh, look. Oh, there you go. So rows, and then I also want this here. The left is the row. So the row is 1, 2, 3, 4, 5, 6. Yep. 3, 4, 5. 1, 2, 3, 4, 5, 6. And it's 7 there. So starts off checking some stuff. So 0, 1, 2, 1, 2, 3, 4, 5, 6, 7. Yep. And then it hits the right spot there. Yeah. It hits the right spot. It does an and it outputs the correct thing. But then if we add one of these, for example. Oh no, that's not the correct thing at all, is it? Because it should be the other way around. Yeah, it should be the other way around. We should have a bunch of ones. So if empty, there we go. Alright, that didn't take that long. The issue was basically a continue statement that was here, and I wasn't actually doing the bit shifting. Now I'm doing it every single time of Galaxy 2, and we're at the correct number, which is 6, but again, no duplicates. No duplicates, so a good place to start would be by saying that you have to start you can only go 256 minus K1. Yep. But also you don't go grid row. Row again equals grid at I. We go grid dot length and not 0, 0 dot. We go yeah, let's do an I there instead actually. J. So we have to go from I, yeah, 3. Yeah, I think hopefully that does do what I want it to. 36, great. We can get rid of that. Found galaxy. Can I get these on the same one? So basically this just goes over and checks on an increment, right? So right, because throw again. No, I'm gonna leave it here. I don't really care. Found galaxy pair. Okay, so if we found our pair, print distance, the x distance and the y distance. So the x distance is going to be distance between k1 and k2. Now that k2 is always going to be bigger, not necessarily. K2 is never going to be as big, so k1, k2. Yeah. And then for the y, I guess we're just going to go j minus I. Yeah. Yeah. Integer overflow. K2, K1. Who knew, so that was not going to be all that straightforward. Var dist is 0 if k1 bigger than k2, dist is equal to k1 minus k2, else dist is equal to k2. This is really lazy, but make you u256. We found galaxy and also down here. These are my pairs. I mean the distance between the pairs. So 4 and 1. I'm guessing it's this one. 1, 2, 3, 4, and 1 down. That's good. But now we need to work out if crossed any lines like. So I have. Oh god. Okay. The number, we need to do kind of an intersection here between 4, 1. Okay, so I think I kind of figured it out. Also, I just turned on my brain to realize that it was just an or. What we have to do is let's start with rows. Let's start with rows. Well, step 1 is to shift right the math.min of the dist. No. Rows, if we're checking, we go through rows, then it's the y value, so it's j minus I. Or not j minus I, j and I. To see which ones are relevant. So we go r equals rows. R equals r, shifted to the right. Standard.math.min, deprecated, min int. Okay. Function min takes in num1, u256, num2, u256. Oh, no, just returns u256. 256 if num1 is bigger than num2, turn num1, turn num2. The min of, and we have to, do we have to truncate it? I don't know actually, between j and I. And again, let's just get rid of this here. Here we are looking for some stuff, I guess. And then we will go through while r is bigger than 0. If r modulus 2, no, and 1 is equal to 1, then found row. Here is a row. I don't think this will do anything now, but expected type u8 found u 256. So let's truncate. Yeah. Min, which is a u8 equals I truncate the min between j and I, and min m. There we go. Lovely, goes on forever because we forgot to do r equals r shifted over to the right once. Here is a row. I really don't think there is one there. Print row. R. There are no empty rows. Oh, but yeah, the 1 and the 0. Yeah, because there's the one that's like a flag to the left. I mean, do I need that? Like, do I actually need that? Maybe I don't. But then it does make it hard to know some stuff, like that's the pairs, this is the rows 1 0 0 0 1 0 0. So starting from the bottom goes 0 0 1 0 and then 1 and then it never does it again. So I guess we could start off by actually taking the rows. Oh god, this is so frustrating. But I'm really not good at this like specific type of thing. Oh, but yeah, it's really not good. Yeah, I need to go back to thinking. annoying logic, but I think I got it. So basically I need to change the found to be if the rows aren't equal, or if the rows are equal, we get K1 and K2 are not the same because they're the x-axis, and the K2 has to be bigger than K1. That's because the bigger it is, the further left it is. And I think that works. I got 374. We can get rid of this. This is a pretty bad solution. Like, the binary really, really hurt things. I spent like an hour trying to figure out just stuff that, you know, is annoying. But I think that's the example answer. With some luck, this will work. Doesn't look bad. Too high. Too high, it says. Oh, I think I know where this breaks down. This breaks down in places like this. Where, yeah, oh, 3 pairs. No, that's fine. Okay, let's think. So the 3, this one here, with the distance of 3. The 3 to the 9, the 5 to the 9. No, that works. That works well. So there must be another edge case that I'm not getting. Maybe let's test just this. No, that works. So the distance between 1, 2 and 1, 6 is 1, 2, 3, 4, 5, 6. That's correct. So what is going on here? It said too high. What if I'm off by 1? That would have been great though. Oh, I'm not sure. This is me realizing that I'm just not going to find a bug in that binary solution. I'm too weak. I am just too weak. Can't do it. Yeah, I probably could have, but to be honest, I didn't really want to stare at the screen for this long. Empty rows dot put 0 dot I. Yep. Yep. Now we gotta go through columns instead. So dot input 0 dot length I, and then for 0 dot input dot length j. Empty call equals true if input at so we're checking columns here, so j no, that's a row. Wait, what am I doing? I need to go through columns, so each time I need to go through all the rows. J at I is equal to a hash, then empty call, then empty call dot equals false. If empty call, then we try empty calls dot put I. And we're going to print calls any empty calls, empty rows. Just make sure we have the example. You know, now we know how to do it, so a rewrite should be pretty straightforward anyways. But a 1. So I basically just, you know, dot count so calls 1 2 3 2. Yeah, that's probably right. And this, yeah, we don't even need to pass the input into anything binary. We already have it, so you know, it's not even about efficiency. That was really silly of me. Okay. Now is where we go through it again, like we go through each one. So for 0 dot dot input dot length I, for 0 dot dot input 0 dot length j, if input I j is equal to, not equal to hash, continue, otherwise found 1, and then, yeah, 0 dot, and then we need to duplicate these, don't we? Again, so that stays the same. I2, J2. A and B. But only that we do want to start on the same row. Yeah, on the same one at least, right? So I, and in terms of column, yeah, we're gonna have like the same issue here, which is, yeah, we'll get to it in a sec, but what we need to do here is go and say not in there but in here, let's have pairs again. Pairs size 0, pairs plus 0 for 1, pairs, in our example, too many, way too many, way too many because, you know, maybe I don't really bother with that. I'm going to be like inefficient and just say var checked is equal standard dot auto hash map. Just gonna I mean, do I actually have to do this? I to input length. Oh, wait. A, B. Yep. 46. 46 is better. If I is equal to A and J is equal to B, continue. If I is equal to A and B is smaller than J, continue. And we can put them all in one, but there we go, okay. Correct. So now, what we need to do, say the distances for, so I is smaller, always, so I dot dot A. This one can be +1 even. Okay. If so here we're going to check for the rows. If row empty rows dot get K, if this number exists in there, dist usize equals 0, dist lesser equal 1. Right, we're going to add 1 for each row. Each row multiplier. And then we're going to check the columns. We're going to check the columns, right? So we're going to go between just trying to think. Oh yeah, the lowest. This is like where max and min come in useful. Yeah, because rows we can kind of be certain, but not these. There's no need for you, no need for you, no need for you, no need for you. Okay. For the minimum between J and B, dot dot the max between J and B. Okay. Actually, the distance is going to be A minus I plus max J comma B minus min J comma B. And dot 1. Oh no, so I'm guessing that A, oh yeah, no, that should be fine. What's it on about? Is it that? Can't be it, right? That was it. But we're getting quite an incorrect answer. Crossed rows, usize. Crossed calls, usize 0. You know, before we do that, let's actually just print galaxy1. And galaxy1 is going to be I. Let's do J and I. And B and A. Oh, and distance. Let's check them out against this. 1 and 7. 1 and 7. 3. 7 is this one here, right? Yes, it's going to have x of quite a bit and y of 8, 7, 1, 0, 1, 2, 3, 4, 5, 6, 7. Yes, this one's 17. It says 17. No. It says 17, but it should be less. Look at this duplicate for loop. Lovely. Oh, that's great. That's basically the same logic I had with. Okay. The galaxies are much older and thus much further apart than the researchers initially estimated. Now instead of the expansion you did before, make each row or column 1 million times larger. Okay. Let's go with 10 to start with. Yep. So we're taking away 1 million. And you know what? Let's go straight into it. Let's just do that. Very big number. All right, cool. So after an intuitive rewrite, I was able to do this day fairly easily. Okay, thanks so much for watching, and I'll see you tomorrow.